Hello and welcome to Khaliltronics. In today's video, we are going to look at integration from the basics level. So basically, integration is a reverse process of differentiation. When we differentiate, we start with an expression and proceed to find its derivative. When we integrate, we start with derivative and then find the expression from which it has been derived. So for example, if we have let's say for instance, for example, so if we have derivative of the respect to x of, let's say, 4x or x raised power 4, so the differential of this actually is 4x raised power 3. So since the differential of this function, the function is given as y is equal to x raised power 4, so the differential of this is going to be 4x raised power 3. But if you reverse the case, if we integrate this function, it will going to give you this. So it's the reverse process of differentiation. So meaning that if we integrate the 4x raised power of 3, it will give you this. So that's why it is a reverse process of integration. So we are going to look at the table here and then explain the function, and then it is what integral. So the symbol of this integral, that's the symbol of integral of f of x is with respect to x. So here is with respect to x. So this symbol is denote the integral of f of x with respect to the x variable, and then the symbol of this integral was developed from the capital X. So it's developed from the capital X, which it was used in 17th centuries when the ideas of calculus were first derived. The expression of f of x, this expression, that's f of x, so this y, so it should be the expression, so it should be like 4x. So it's the same thing as y is equal to 4x, or the function expression f of x should be equal to x power 4. So this expression f of x is to be the integrated is called integral, and then differential dx. And then dx is usually there is no there is to assist in the evaluation of certain integral. So it's just to help in the evaluating the integral of f of x. So that's why we denote it, instead of x we used what integral. So it's all the same. So we are going to proceed with the table to see how the table works, and then a lot of things. So basically this here is x of n. So if you have, let's say, f of x, if you have f of x as x power n, so the integral of this is equal to x raised power of n plus 1, and then whatever in the power is just here in the denominator. So that's n plus 1, then plus the constant term, which is c. So if you have such function, so the integral of it should be this. And then if you have a constant term, let's say you have 1, so the integral is just x plus c. And if you have a, is just what ax plus c. Like if you have constant term, let's say integral of 200, you can just say 200x plus c, so and so forth and so on. So, and then if you have sine, the integral of sine, like if you have integral of cos x is just what, sine x plus c, and if you have integral of sine x is just what, minus cos x plus c. So it's the reverse process. In differentiation, the differential of sine is cos, while here in integration the differential of sine is minus cos plus c. So you should take note. And then if you have exponential of x, that's the integral of this should be e to the x plus c. And then the integral of, if you have integral of 1 over x is equal to ln x plus c. And then for this, if you have integral of ax raised power of x should be a power x, then ln of a plus c. So this is how the thing is going. So we are going to use the formula to solve some problem. So let's proceed. Okay, so I remember to explain where the c, that c is equal to a constant of integration. So I remember to explain where does it come from. So actually, if you have, let's say, if you have the derivative of 4x or x to the raised power of 4, so we know that the differential of this function should be what, 4 at the back, that's 4 times the coefficient x raised power of 4 minus 1, which is equal to 4x raised power of 3. So since the differential of this is just to this, and then if we integrate the function, if we integrate this function as 4x raised power of 3, it will give us what, x raised power of 4. So as you see here is just the reverse. If you differentiate this x raised power 4, it will give you 4x power 3. And if you integrate this function, that's 4x raised power 3, it will become the normal function, which is what, this. But in another case, if you take, in the case of this, let's say if you have a differential of, with respect to x, differential of x power 4 plus 2. So in this case, we will have, if we differentiate this, we will have 4x power 3, the same, then plus what, here the differential of constant term is 0, so it's just plus 0, which is what, 4x power 3. But if you want to integrate this function, like you are trying to integrate, saying that 4x raised power of 3, integral of this, it will give you what, 4x power 3 plus 1 all over what, 3 plus 1. So like here we don't do it, that's why we just, so here we can say 4x raised power of what, 4x raised power of 4 over 4, and then 4 goes is 4, and then we have x raised power of 4. So as you see here, the reverse process of this is not the same with this. Since the reverse process, the original function is x raised power of 4 plus 2, and then after we reverse, we get this, we get x power 4. So hence it's not equal. So we are to add what, the constant of integration, that's c, so that c could be able to find, maybe could be able to be unknown or certain number is just a constant. So actually if you differentiate, you have to add c in case if there is constant term. So if you integrate this, if you have, let's say, integral of x power 4, if you have integral of x power 4, you should just say x raised power of, let's say, 4 plus 1 all over 4 plus 1 then plus c, which will be x raised power 5 over 5 plus c. So c should be constant, it must be included. If c doesn't include, if you haven't include c in your equation, the equation should be not completed. So we are going to take some questions to start solving the problem. So this is some basics. You have to understand this before we proceed. And then in some certain case, you could have the value of function, and then to find c, we will look on it very soon. So let's take some example and solve. So here is certain questions. So we're gonna start from A to J. So taking number A, solution. So taking number A, in the number A we have integral of x raised power of 6 dx. So to integrate this, since it's x raised power of n, so the integral of this we have is as a formula method, which we can say n plus 1 all over n plus 1 plus c. So integral of this should be, since our n is 6, we can just say x power 6 plus 1 all over 6 plus 1 then plus c. So this should be x raised power of 7 all over 7 then plus c. And then question 2 is this A. So for B, we have integral of 3 exponential of x dx, that's with respect to x. We already know that from our table, integral of x, exponential of x is equal to exponential of x. So we can say integral of this, we can move these 3 out, so we can have 3 integral of exponential of x and dx. So exponential of this is just the same, so we can say 3 times exponential of x, which is what, 3 exponential of x, since the whole integral of this with respect to x is exponential of x. So 3 times this is 3 exponential of what, x. So taking the next question is integral of 6 over x. That's question C. Find integral of 6 over x. So then the x, then from our table, if you can remember, we have something like this. If you have integral of 1 over x is equal to ln x then plus c. So from here we can say we can rearrange or make this to be equal to, like saying that this 6 over x dx is equal to 1 over x then times 6, then we say dx. So 6 will go out, we can say 6 integral of 1 over x dx. So then we can say integral of this is equal to what? Integral of 1 over x is ln x, then times 6, we can say 6 ln x. So question number 3 is 5 sin x dx. So question number D, we have find integral of sin x dx. So integral of sin x is just what? Is just cos minus cos. So we can say it's minus cos x plus c. And then the next question is x square. but remember here there is 5, then here should be minus 5 cos x plus this. Then e is integral of sec square x then dx. So it's just from, according to the table, you can just use table. Sec square x is just tan x plus what c. So this how it should be. Then let's take the other questions and see. The next question is integral of h. So integral of h, that's, let's say, f integral of h dx. So this is constant term. The integral of this is just what hx is just what h x plus c, and then you can also say h raised power of x power 0 is just what is 1. So then you can apply our formula, then plus 1 here all over what 0 plus 1 plus c. Here we can say h x 0 plus 1 is just 1 all over 1 plus c. Yeah, we can see plus what plus c. So answer should be h x plus what c. So looking at this, so this cost is just this for this costs, this one integral of this cos 2 cos x dx is just what 2, since the integral of course is just what sine, so you can say 2 sine x plus c. So for this question also, this question so for this question, integral of this x raised power minus 3 dx, we can also say our n is minus 3, we can say x raised power minus 3 plus 1 all over minus 3 plus 1 then plus c, and then this equal to equivalent to x raised power of minus 2 all over minus 2 then plus what c. And then the next question is j, and then j is integral of x raised power 4 raised power of x dx. So basically this from the table, and then from our table, if you have a raised power of let's say x should be equal to a power x then divided by ln of a then plus c. So our a is just 4, so we can say 4 power x all over ln 4 then plus c. So this is how it works. So let's take a numerical example so that we can be able to understand the concept. So let's say we take some rule. So if you have f of x is equal to 4x square, let's say cube plus 3x s power 4 plus 9x square plus 6x plus 7. So we are trying to find the integral. So to find the what integral, we can say this function should be integrate this, so we can be equal to integral of 4x raised power 3 plus 3x raised power 4 plus 9x square plus 6x plus 7. So here we can just apply our formula. You can say 4x raised power 3 plus 1 all over 3 plus 1 plus 3x raised power 4 plus 1 all over 4 plus 1, making it what 5 plus 9x 2 plus 1 all over what 2 plus 1 is 3, then plus 6x raised to the power of 1 plus 1 all over 2, since the sum is just 2, then plus 7x raised to the power of 0 plus 1 all over 0 plus 1, then plus c. So we can also say 4x raised to the power of 4 over 4 plus 3x raised to the power of 5 over 5, then plus 9x raised to the power of 3 over 3 plus what, 6x squared all over 2 plus 7x plus c. So here this goes this, we can have x squared, x raised to the power of 4 plus 3 over 5 x raised to the power of 5, and then plus 9 by 3 is 3 x raised to the power of 3 plus 3x squared plus 7x plus c. So this is just a numerical question. This is how we should integrate if the function is given. So let's take another question, the question that we can be able to find the constant term known as what, c. That's c. We should find the c. Let's look at the types of questions. Okay, so another set of question is given saying that if I is equal to integral of x raised to the power of 3 minus 3x squared plus 4x then minus 5 then dx. So it said to determine what, the value of the I when x is equal to 3, given that at x equal to 2 I is equal to what, 26. So there is 4 steps to solve these problems. The first step is what, the first step step 1, that's step 1, is to what, is to perform the integration. It's just to perform the integrations. And then the second step is to what, is to express the resultant function in nested form. So the second step, that's step 2, is to just what, express the resultant function in nested form. So it's just to, but let's follow bit by bit. So let's start with step 1. Step 1 is just to perform the integration. So we are to take this, it says I is equal to integral of h raised to the power of 3 minus what, 3x squared plus 4x minus 5 then what, dx. So our step 1 is to just perform the integration. So you can just apply formula x power n is equal to x raised to the power of n plus 1 all over what, n plus 1. So we can simply say we have h raised to the power of 4 over 4. Here is what, if you add here is what, 3 plus 1, or you can, let's say so that anybody can be able to understand, that's 3 plus 1 all over 3 plus 1. And then for here we can say 3x raised to the power of 2 plus 1 all over 2 plus 1, and then the next one is plus 4x raised to the power of 1 plus 1 all over what, 1 plus 1, and then the last one is what, minus 5, that's minus 5. So if it is normal you can just say minus 5x, but since we are going to show it's just 0 plus 1 all over what, 0 plus 1, and then plus what, c. Don't forget to include what, c. So here by simplification we can say h raised to the power of 4 over 4 minus 3x raised to the power of 3 over 3 and then plus 4x squared all over 2 minus 5x then plus c. So here into here, h by 4 is 2, that's 2x raised to the power of 4 minus 3 by 3 is 1, that's x power 3 plus 4 by 2 is 2 raised to the power of that's x squared minus what 5x plus what c. So our I is going to be equal to this. So this is the what step 1 is to just what perform the integration. So this is our very own step 1, and then step 2, that's step 2. Step 2 is to just express the resultant function in nested form. So this is this is the integration. Just perform the integration, and then the step 2 is here. So our nested form is equal to what 2x power 4 minus what x raised to power 3 plus 2x square minus 5x plus c. So step 2 is just to make it in what nested form. So step 1 is just to perform integration. So this is where the step 1 is end. That's for step 1. This is what for step 2. So the step 3 is to what evaluate the constant of integration by using the facts. Since from our questions we have what it says that we are to determine the value of I when x is 4, and then given that at x is equal to what minus 2, at x is equal to 2 we have I is 26. So we had to find what constant of integration c at step 3. So but to find this we can use both x and y. So at x equal to minus 2 you should use what I is equal to what 26. So okay, so sorry. So our step 3 is to what find what constant of integration, that's c. So we have the relationship at this. So to find this we should use what when x it said at x equal to 2 we have what I is equal to what 26. So we just substitute this value into the step 2. That's our equation. So we have I is equal to 2x raised to power 4 minus x raised to power 3 plus 2x square minus 5x plus c. So we have I as 26. We have x is 2. That's 2 power 4 minus 2 power 3 plus 2 into 2 square minus 5 into a 2 parentheses plus what c. So we are looking for what c. That's the constant of what integration. We are looking for c. So from here we can say 26 is equal to 2 times what 2 power 4 is what 16 minus 2 power 3 is just 8 plus 2 power 2 is what is 4 times 2 is what 8, then minus 2 times 5 is what 10 plus c. So here goes here h minus h plus h go. Then we can say 26 is equal to 16 times 2, that's 32. So we can say 32 minus what we have 10 then plus c. So we can say 26 is equal to 2 times 10, which is what 22 plus c. So making subject of the formula, making c to be subject, we can say c is equal to what 26 minus what 22. So we can have c as 26 minus 22 to be equal to what 4. So since we find the 3, so the final step is to just what evaluate the I. Is to evaluate the I. That's step 4. We can say step 4 is to determine the value of I. Is to just what determine the values of what I. So from our questions it says to determine the value of what? To determine the value of I, to determine the value of what? The I is to determine the value of what? I when what? X is 3. So when x is 3, we have to determine the value of I. So when x is 3, when x is equal to 3, then we have to determine the value of I. So using our we have I as what? From our nested integrations, we have it as 2x raised power 4 minus x power 3 plus 2x square minus 5x plus c, as we have it here, right? So we have it here, right? So what we need to do is to just substitute for x when x is 3, and we have what? C as what? 4. So we can easily find what I, since we have x, we have x's, and then we have c. So we can say we have 2x, our x is 3, that's power 3 minus x, sorry, our x is 3, that's power what? 3, here is is power 4. Then we have 2 into 3, and then square minus what? 5 into what? 3, then plus c, our c is what? 4. So we can easily say our I, it should be 2 into what? 3 power 4 is 81 minus 3 power 3 is just 27 plus 9 times here is 2, 3 power 2 is 9, then minus 5 times 3 is just 15 plus 4. So we can also say 81 times 2 is just 162, then minus 27, then plus what? 18 minus 15 minus 15, then plus 4. So by summing this, you should have the value of I. If you sum this correctly in the calculator, you will have the value of I to be equal to 142. So then our I, therefore our I is equal to what? 142. So this is how to solve the question. Remember, the step 1 is to just perform the integration. Step 2, express the logarithm function in nested form. Step 3, evaluate the constant of the integration. And then lastly, step 4 is to determine the value of I when x is what? Already given. So this is the basic of integration. In our next video, we are going to see the integrations of a function, maybe integration by part, integration with limit, and many more. So thank you for watching. Don't forget to subscribe, hit a bell icon, give a like and comment. Thank you for watching.